You've probably felt it already. For weeks, Sleepy Universe has been following 3i Atlas night after night, tracking every shift in brightness, every new data point, every quiet change that caught the attention of astronomers around the world. And we're still watching, closely. Nothing truly new has been confirmed yet, but the moment something real arrives, you'll hear it here first. Tonight isn't a replacement for an Atlas update, it's preparation. The time between headlines isn't empty. It's the space where you build the understanding that makes each update clearer, quieter, easier to hold. Because on December 19th, Atlas reaches its closest point to Earth, and even then, the distance is so vast that your senses have no natural way to grasp it. That's the part most people misunderstand. Closest still means tens of millions of kilometers. Closest still sits far outside anything your intuition can measure. And to truly read every Atlas headline with confidence, you need a way of thinking about distance that doesn't rely on instinct at all. So tonight, before the next chapter arrives, you and I will step back and understand the one thing that shadows every story about Atlas, the kind of distance your brain was never designed to comprehend. Let's understand the one thing that breaks every intuition we rely on: distance. You settle a little deeper into the quiet around you, letting the noise of the day fade into the background. You came here you want something calm, something steady, something that gives you a sense of perspective without demanding too much of you. You want that feeling you get when the universe suddenly makes a little more sense. So let's start with something simple. Picture the spot where you live. Maybe a quiet street in the suburbs. Maybe a farmhouse road where the nearest light is a porch lamp. Maybe an apartment balcony overlooking a city that softens when the evening settles in. You can tell instantly how far away the nearest streetlight is. 30 feet. 40 maybe. You don't need instruments. Your brain was built to measure it for you. Now stretch it. 100 miles. You think of the drive between cities, Chicago to Milwaukee, Dallas to Austin, places you've been, roads you've taken. Your instincts still know what that means. But now, imagine 1,000 miles. New York to Miami, Los Angeles to Seattle. You can't picture the whole route anymore, but your intuition still has something to hold on to. The sense of crossing several states, the feeling of time, distance, and terrain changing around you. Then someone asks you to imagine 1,000,000 miles. That's where it breaks. 1,000,000 miles has no shape in your mind, no weight, no texture. You can't feel it the way you can feel the driveway, the neighborhood, the state line, the width of the country. 1,000,000 miles is just a number. It floats in your head with nothing to attach to. And here's the part that surprises most people. 1,000,000 miles is tiny in space. Earth is 93 million miles from the sun. Earth travels about 1.6 million miles every single day just by orbiting. 1,000,000 miles is a rounding error on a cosmic map. Now try 10 million miles, then 50 million. Then the distance 3i Atlas will still have from Earth on December 19th, even at its closest point. A moment that astronomers call close, only because they live in a universe where close is defined on a scale your intuition can't feel at all. That's why the universe uses light years. Not because they sound dramatic, not because they make astronomy sound mysterious, but because at cosmic scale, Every unit you've ever used breaks instantly. Miles snap, kilometers shatter. Even the astronomical unit, the distance between Earth and the Sun, collapses under the weight of the stars. And here's the part you came for. By the time you reach the end of this journey, you won't just know what a light year is. You'll understand why your intuition never stood a chance. You'll see why astronomers abandon human-scale thinking and reach for the fastest thing nature allows, light itself, just to measure the spaces between things. Tonight, you and I step across the line where intuition stops working, and a new kind of understanding begins. Look at the distance between Earth and the Moon. About 384,000 kilometers, 238,000 miles. You can't picture that. There's nothing in your life that reflects that scale. No drive, no flight, no road trip, no cross-country move has ever come close. It's the first distance your brain can't feel. And that's just our moon, our closest neighbor. Now take the distance between Earth and the Sun, about 150 million kilometers, 93 million miles. This number is so far outside your evolutionary toolbox. Even if you multiply 3,000 miles again and again, stack it 100 times, 1,000 times, your mind has no way to visualize the final sum. So let's try something familiar. Imagine driving to the sun. If you got in your car, set your cruise control to a steady highway speed, say a comfortable 100 kilometers per hour, and pointed your headlights straight toward the center of the solar system, you would arrive in the year 2195. Not tomorrow, not next year, not in a decade. It would take you 1.7 centuries of continuous driving. And that assumes your car doesn't break down, your tank never runs out, and the road ahead exists forever. Even the astronomical unit begins to fail the moment you step beyond the solar system. And so the only logical question left is this. If our built-in instincts don't work at cosmic scale, and kilometers collapse under the weight of the stars, what did humanity invent to overcome these limits? And so, humanity invented a new kind of yardstick, one built from light itself. Light is the fastest thing the universe has allowed to exist. Nothing outruns it. Nothing even comes close. It moves at 300,000 kilometers per second, so fast that the beam from a flashlight would lap around Earth 7.5 times before you could blink. It is so constant, so reliable, and so woven into the structure of reality that Einstein once said, "The speed of light is not just a constant. It is the structure of space and time." When astronomers realized how quickly intuition fails, they did something powerful. They stopped trying to stretch human-scale units upward. Instead, they built a new scale from the top down. They asked a simple question. If light moves at the same speed everywhere, in every direction, at every moment, why not use it as the ruler? And so the light year was born. The distance light travels in a single year. 1 light hour. 60 minutes of light racing at its absolute limit. In that time, the beam travels 1.08 billion kilometers. That's not a typo. Billion. The kind of number you only ever saw in news headlines about national budgets, now becoming a simple step on this new ladder. Keep going. 1 light day. 24 hours of light at full speed. That's 26 billion kilometers. enough distance to leave the inner solar system behind, enough distance to understand why every spacecraft we've ever built is like a paper boat in an ocean we haven't begun to chart. Step higher. 1 light month. 30 days of light racing through the void without slowing, without dimming, without stopping. That is 780 billion kilometers. And at the top of this ladder, after seconds, minutes, hours, days, and months, comes the light year. 9.46 trillion kilometers. Trillion. A trillion is such a large number that your mind can't visualize it. But you can feel its weight if you understand this. If you counted one number per second, 1, 2, 3, without sleeping, without talking, without stopping, you would reach 1 trillion in 31,688 years. You could start counting at the end of the Ice Age, and you still wouldn't be finished today. That is the scale of the universe. That is the reason miles fail. That is the reason kilometers collapse. That is the reason your ancestors never had to stretch their instincts this far. They never needed to. But you do. Because in astronomy, 1 trillion kilometers isn't shocking. It's basic. It's the equivalent of a single block in a cosmic city. A single step on a galactic staircase. A light year folds two ideas into one: distance and time. It is a measurement that tells you not just how far something is, but how long ago you were seeing it. When you look at a star 20 light years away, you're looking 20 years into the past. When you look at one 500 light years away, you're looking back to a world where the first telescopes were only beginning to exist. Every star in the sky is a time capsule. Every star is a record of a moment long gone. This is what makes the light year beautiful. It's not just a tool. It's a window, a translation between human understanding and cosmic reality, a bridge between instinct and infinity. And if you're sensing it now, that growing shift in your intuition, that's exactly what this moment is designed for. You're not memorizing numbers. You're rebuilding your sense of scale from the ground up, using the most universal constant the cosmos has ever offered. And this new scale matters because soon you'll use it to understand your cosmic neighborhood. The stars that sit closest to Earth are not thousands of light years away. They're just a few steps above the sun on this ladder. Only 4, 5, 8 light years. Close, yet unimaginably far. Familiar, yet unreachable. Beautiful in their nearness, but mind-bending when you remember the size of the yardstick itself. And that is the next step in our journey. Using this new ruler to look outward, beyond planets and orbits, toward the stars next door. The ones whose light has been traveling for years just to meet your eyes tonight. The ones that show you what close really means when the universe sets the scale. Now that you can feel what a light year truly is, let's visit the stars closest to home. You've built a new way of feeling distance. You've climbed the ladder from light seconds to light years, letting each step settle into your mind until the numbers stopped sounding impossible and began sounding natural. Now, it's time to use that new intuition in the place where it matters most. Your own stellar neighborhood. Because even here, even in the region closest to home, the universe wastes no time reminding you how small your instincts truly are. Start with a picture. Imagine the solar system as a tiny pocket of warm light floating in a vast, cold ocean. The sun sits in the center, glowing steadily, holding a family of planets in its grasp. But beyond those planets, beyond Neptune, beyond the Kuiper Belt, beyond the scattered disk, the warm light fades into darkness. Not danger, just distance. A distance so deep that even space itself feels different. The sun is an ordinary star, not large, not small, not young, not old. It is one yellow pinpoint among hundreds of billions in the Milky Way. And the region around it, our stellar neighborhood, is unbelievably empty. If you shrank the sun to the size of a marble, the closest other marble would be several thousand kilometers away. Our neighborhood is not crowded. It's not even mildly busy. It's a quiet suburb on the edge of a cosmic city. The closest star? Proxima Centauri, a small, cool red dwarf that glows faintly in a direction your eye could never distinguish. Its distance? 4.24 light years. You now know what that means. You can feel it. Light, moving at the fastest speed the universe allows. Takes more than 4 years to travel from Proxima's surface to your eyes. The glow you would see from it tonight began its journey before the last presidential election, before countless human moments you've lived through since then. So let's ask a practical question. What if humanity wanted to visit our nearest neighbor? Even with the fastest spacecraft humanity has ever built, the Parker Solar Probe, it would take tens of thousands of years to reach Proxima Centauri. Tens of thousands. Longer than the span of recorded human history. Longer than the time between the first stone tools and the pyramids. If ancient Egyptians had launched a probe toward Proxima during the reign of Ramses II, that spacecraft would still be drifting through interstellar emptiness right now, nowhere near its destination. This is what close means in space. That's why, when people hear that 3I Atlas will be closest to Earth on December 19th, the word feels misleading. Atlas's closest approach is still only a few tens of millions of kilometers, which is tiny compared to a light year. Atlas may be a visitor from beyond the solar system, but at this moment, it is still firmly inside our cosmic backyard. The stars, even the nearest ones, remain unimaginably farther away. Now look beyond Proxima. Just past it sit two brighter, hotter, more familiar-looking stars, Alpha Centauri A and Alpha Centauri B. One slightly bigger and brighter than our Sun, one a little smaller. They orbit each other like two lanterns circling in the darkness. If you lived on a planet in that system, if your sky were painted by two suns rising and setting across your alien horizon, your daylight would come in two colors. Your shadows would split in double directions. Your seasons would twist around the dance of those two stars. It's beautiful to imagine, and still impossibly far. So, humanity began to dream bigger and more practically. Scientists asked, what if we can't send a ship full of people? What if we send something tiny instead? Something so small and so light that a powerful laser on Earth could push it close to the speed of light. That idea became Breakthrough Starshot. The concept is simple on paper, but breathtaking in reality. Build a sail the size of a postage stamp. Attach to it a spacecraft the size of a computer chip. Fire laser beams from Earth that accelerate the sail to 20% the speed of light. Send it toward Proxima Centauri. At that speed, the tiny craft could cross the interstellar void in about 20 years. Then its signal, a weak radio whisper, would take another 4 years to travel home. A full round trip, 24 years. A science mission old enough to graduate college. But that dream has challenges that sound almost poetic in how harsh they are. A single grain of dust at 20% of light speed could destroy the craft instantly. The laser array required would demand more energy than any system humans have ever built. And once the craft arrives, it cannot slow down. It can only flash past the system in an instant, gathering what data it can as it hurtles through the darkness. We imagine interstellar travel as heroic, cinematic, full of engines roaring and ships gliding between stars. But in truth, even our boldest plans are tiny, fragile chips of silicon riding on a beam of light. And yet those fragile hopes represent the best chance we currently have of reaching even the nearest star. This is the scale we live in. This is the neighborhood around your sun. Proxima Centauri, 424 light years. Alpha Centauri, A and B, roughly the same. Barnard's Star, about 6 light years. Wolf, 359, a bit more. Luton, 726 to 8 or so. These are the closest porch lights in the cosmic suburb. And each one sits at a distance that shatters every rule your intuition tries to apply. Imagine if Proxima Centauri were the next town over, your fastest spacecraft, the fastest thing humanity has ever touched, would still feel like walking there on foot. And that's the quiet truth most people never realize. It is distance, not danger, that keeps the stars apart. It is distance that makes the universe feel silent. It is distance that turns our solar system into an island of warmth, surrounded by an ocean so deep that even light itself takes years to cross it. But that distance isn't discouraging. It's humbling. It's beautiful. Because once you begin to think in light years, the sky above you stops being a ceiling and becomes a map. A map written in the only unit big enough to describe the separation between worlds. Stephen Hawking once said, "Spreading out into space will completely change the future of humanity." And Yuri Milner added, "For the first time in human history, we can do more than just look at the stars. We can plan to visit them. Maybe those visits won't come in our lifetime. Maybe they won't come for hundreds of lifetimes. But the fact that we can imagine them, the fact that we can measure them, is already extraordinary. Because even understanding the distance to the nearest stars puts you in a rare group. Most people read the number. They don't feel it. You now do. You're no longer using miles or kilometers. You're using the universe's own ruler. And that ruler tells you the truth. Our neighborhood is enormous, empty, quiet, and astonishing. But distance doesn't only separate stars. It separates moments. When you look at those stars tonight, you're not just looking far away. You're looking back in time. But light years are not just about how far things are. They are also about how far back in time we are looking. Every time you look up, you are looking back. It's one of the simplest truths in astronomy, and one of the most quietly staggering. Light takes time to travel. It doesn't matter whether it comes from a planet, a distant galaxy, a red dwarf, or a comet crossing the inner solar system. What reaches your eyes is never the present. It is always a moment that has already happened. When you stand under the night sky, you are not just seeing stars. You are seeing history. Take Sirius, the brightest star in our night sky. It sits about 8.6 light years away. That means when you look at it tonight, you aren't seeing it as it is now. You're seeing it the way it was in 2015. Think about where you were in 2015. What your life looked like. What you hoped for. How different the world felt. While you lived every minute of the last 8 years, the light from Sirius made its long, steady journey across space to reach you tonight. Now look at Vega. Bright, bluish, easy to spot on a clear night. It's about 25 light years away. If you're around 45 or 50 years old, something extraordinary happens. The light hitting your eyes tonight left Vega when you were a child, when you were learning to ride a bike, when your world was only a few blocks wide. The glow you see tonight began its journey before you knew anything about the universe at all. Then there's Pollux, about 34 light years away. That means the light you see tonight left the star in the late 1980s, before the internet was part of daily life, before smartphones, before GPS, before most people had ever sent an email. That star has been shining steadily through the entire technological transformation of modern society. And only now has its light finally reached you. But those are just the close ones. Step deeper into the sky, and the timeline stretches beyond anything personal. Look at Betelgeuse, the red supergiant in Orion. It sits roughly 550 light years away. That means you are seeing it as it looked in the 1470s, the heart of the Renaissance, centuries before telescopes were invented, when much of Europe was still illuminated by candles. The light that hits your eyes tonight began its journey before Columbus crossed the Atlantic, before Shakespeare was born, before the printing press reshaped human knowledge. And here's the part that creates a quiet shiver. Betelgeuse is unstable. It will one day explode as a supernova. It might have already done so. If that explosion happened any time within the last 5 centuries, we just don't know yet, because the light hasn't arrived. Somewhere out there, an event may have already reshaped the star, but for us, it hasn't happened. Not yet. This is what it means to live inside a universe where distance is measured in light time. We live inside a delay. The night sky is not a photograph. It is a museum of light. Every star is an artifact from a different era. You are not just stargazing. You are time traveling. Polaris, the North Star, sits around 445 light years away. The light you see tonight began its journey before the United States existed, before the Declaration of Independence, before the first Europeans reached the interior of North America. The light you see left Polaris before many of your ancestors ever set foot on the continent you live on now. Think about that for a moment. The sky you see as constant, eternal, unchanging, is built from light that remembers a world far older than yours. And now, bring it closer to home. Bring it back to something you've been tracking with close attention. 3i, Atlas. For an object inside our solar system, the light delay is small. Seconds, sometimes minutes, but it's there. Even when astronomers say they're watching Atlas in real time, they're not. They're watching it as it was moments ago. Every frame, every brightness change, every shift in its coma arrives slightly late. Even at this tiny scale, the universe insists on reminding you that distance and time cannot be separated. If light needs 8 minutes to reach Earth from the sun, then the glow from a comet halfway across the inner solar system must also arrive late. Not dramatically, not centuries, but enough to prove a profound point. You never see the universe as it is. You see it as it was. And this is where astronomy becomes more than numbers, more than calculations, more than telescopes and diagrams. It becomes personal. Because when you stand outside on a clear night and tilt your head back, you are not simply witnessing points of light. You are witnessing eras layered on top of each other. You are witnessing the aftermath of events that happened before your parents were born, before nations existed, before entire civilizations rose and fell. You are watching a cosmic timeline unfold across the sky. Carl Sagan once said, "The cosmos is also within us. We are made of star stuff." Tonight, you feel the other half of that truth. The cosmos is also behind us. Every direction you look is a window into a different century. Brian Cox put it even more clearly. The night sky is a time machine. The further you look, the further back in time you see. And with every star, that time machine becomes a little more real. So take a moment and let this settle. Some of the stars you love to look at may already be gone. Their light is still on its way. Their stories still crossing the void. But that doesn't make the sky tragic. It makes it profound. It means you are looking at messages that took centuries to reach you. It means the universe is patient, slow, vast, and you, standing beneath it, are part of a chain of events stretching backward through time. Every star is a time capsule. Every constellation is a history book written in light. And now that you understand the scale, you can finally read it. If single stars can carry us centuries into the past, imagine what an entire galaxy does to our sense of distance. When you look at a single star and feel yourself slipping into the past, that's already extraordinary. But now, lift your perspective even higher. Leave behind the nearby stars, the familiar constellations, the quiet neighbors of our sun, and widen your view until the entire Milky Way fills your imagination. Because the moment you do, something new happens. Distance stops being something you measure and becomes something you can't live long enough to sense. Start with where you are. The sun, the warm, ordinary star that anchors your days, sits inside a small, gentle corridor of the galaxy called the Orion Arm, a minor spiral branch tucked between two larger arms. It isn't near the center. It isn't near the edge. It lives in a suburb of the Milky Way, far from galactic downtown. From where you sit, roughly 26,000 light years separate you from the bright, restless core of the galaxy. 26,000. The light leaving the center of the Milky Way tonight will not reach Earth until the year 28,025. Everything you know, every city, every forest, every language, every piece of music ever written, every human relationship that has ever existed is contained inside a thin disk around a star that is nowhere near the heart of its own galaxy. Now imagine the entire Milky Way itself, a rotating disk of stars about 100,000 light years wide, containing somewhere between 100 and 400 billion suns. A population so large that if you tried to count one star per second, you would have to count for more than 10,000 years just to finish the list. But numbers alone don't ground your intuition. So let's shrink it. Imagine the Milky Way reduced to the size of a vinyl record, a classic black disk spinning slowly on a turntable. Even at that scale, the whole solar system, sun, planets, comets, Atlas, drifting through, everything humanity has ever known, would be nothing more than a fine grain of dust on the outer rim. Not a smudge, not a scratch, a dust mote, a tiny flicker of matter clinging to the edge of a spinning galaxy. That's your cosmic address, a dust grain on a record. And the sun? It isn't sitting still. It is orbiting the center of the galaxy, carrying Earth and all its life with it in a sweeping, majestic path. One full orbit takes 225 to 250 million years. That means the last time the sun stood roughly where it stands now in the galactic disk, Earth was filled with dinosaurs just beginning to rise to power. The continents were in different places. The sky was different. The galaxy itself has rotated more than once since the first amphibians stepped onto land. This orbit, this galactic year, is so enormous that the entire span of human existence fits into just a sliver of it. Our species has existed for less than 1% of a single orbit. Civilization, as we know it, occupies an even smaller fraction. A fraction so thin it would vanish completely if you tried to mark it with a pencil on the edge of that vinyl record. Now bring this back to a human lifetime. 80 years. A long, full life by earthly standards. Yet compared to one galactic orbit, your entire life, from your first breath to your last, is roughly 0.003 of a single journey around the galaxy. It is less than a blink, less than the soft flutter of a candle in the wind. You live, love, work, worry, celebrate, and rest within a single heartbeat of one star's immense journey around a spiral disk of billions of suns. And yet, far from making life feel small, this realization softens it. If your problems don't shake the galaxy, maybe they don't need to shake you either. Now fold 3i Atlas back into this picture. This object, this interstellar visitor you've been following so closely, is dramatic on the scale of the solar system. It's a mystery, a story unfolding in real time, a traveler that drifted for eons before crossing our planetary family. But on the scale of the Milky Way, Atlas becomes something else. A single dust grain moving across the rim of a spiral arm. A temporary guest passing through a neighborhood so vast that even its entire journey barely registers. That contrast, cosmic and intimate, enormous and personal, is what gives Atlas its strange beauty. It matters deeply to us because it's happening here, in our tiny corner, in our brief moment. But the galaxy around us keeps turning, utterly indifferent to the drama playing out on our dust-sized patch of stardust. Now picture the Milky Way as a city of stars stretching across the darkness. 100,000 light years wide, billions of glowing windows. And your sun, your home, is just one small house on the very last street of the very last district, glowing quietly in a cosmic neighborhood that few travelers ever pass through. Every story humanity has ever told, every poem, every war, every discovery, every birth has played out inside a tiny glowing speck on the galaxy's vast map. Carl Sagan captured this perfectly. Our planet is a lonely speck in the great enveloping cosmic dark. And Brian Cox echoed the same truth. We are the cosmos made conscious, and life is the means by which the universe understands itself. Some people hear truths like these and feel fear. Others feel awe. But you came here to feel calm, to let the size of the universe loosen the knots of daily life, to remember that even if the galaxy barely notices when civilizations appear and disappear, you can still find meaning in the flicker of time you're given. Because if the Milky Way is this vast, this quiet, this slow-moving, then maybe not every worry needs to fill the whole sky. Maybe the immensity of space gives you permission to breathe a little easier. And the truth is simple. You are small, yes, but beautifully so. You are a conscious spark living inside a structure so enormous that even light struggles to cross it. You've gone from feeling minutes of starlight to years, to centuries, and now to distances so large that no human lifetime can ever experience them. But this galaxy, this city of stars, isn't the end of the journey. It is only one thread in a fabric that stretches far beyond its spiraling arms. And even our great city of stars is just one thread in something larger, a cosmic web of light years. You've stepped back far enough now to see the Milky Way as a single swirl of light, a city of stars spinning across the darkness. But the moment you try to step back even farther, something unexpected happens. The scale doesn't just grow, it changes. It becomes something your mind has never been asked to imagine before. Something so vast and so strange that even your newly built intuition begins to stretch at the seams. Because beyond the Milky Way lies the observable universe, the entire region of space from which light has had time to reach us since the beginning of everything. And its size breaks human instinct completely. The part of the universe we can see has a diameter of about 93 billion light years. Not million. Not billion in distance terms. Billion in light years. Each one of those light years containing trillions of kilometers. The radius alone is about 5 billion light years in every direction. At first, this sounds impossible. How can the universe be 13.8 billion years old, yet the observable region stretches more than 3 times that far? The answer is simple, but quietly revolutionary. Space has been expanding while light has been traveling through it. Imagine running on a treadmill while the floor beneath you stretches away faster than you can move. You run, the treadmill pulls, but the distance keeps growing. That is what light has been doing for 13.8 billion years, crossing space that stretches as it moves. The result is a visible universe far larger than its age would suggest. Lift your perspective to that scale, and the Milky Way becomes just one glowing bead in a web of unimaginable structure. Because the universe, when seen this far out, looks nothing like the starry skies you know. It looks like a cosmic web. Galaxies gather into clusters. Clusters gather into superclusters. Superclusters stretch into filaments. Long, luminous threads made of hundreds of thousands of galaxies. Between those threads lie voids, empty regions so vast that entire galaxy groups could drift through them without touching anything for billions of years. And if you shrank every galaxy down to a single dot of light, you'd see something astonishing. The universe would resemble the neural network of a brain. Bright nodes, long filaments, dark gaps, a structure that looks alive. You've now reached the point in the journey where the title of this video becomes literal. The distance that breaks every intuition your brain relies on is right here. This is the scale where instinct fails completely, not because it's unfamiliar, but because it was never meant to grasp it in the first place. But the cosmic web is only half the story. To understand the rest, you need to meet something deeper, something stranger, something called the cosmic horizon. The cosmic horizon is the ultimate boundary of knowledge, not a physical wall. not a barrier made of matter, but a limit set by the speed of light and the expansion of space. There are regions of the universe moving away from us so quickly, not because they are traveling through space, but because space itself is stretching, that their light will never reach Earth. Not in 1,000 years, not in 1,000,000,000, not if civilizations rise and fall 100 times over. Brian Greene puts it simply: there are regions of space so far away that light from them will never reach us. They are forever beyond our cosmic horizon. Think about that for a moment. There are galaxies out there, whole islands of stars, planets, nebulae, histories, and futures that no telescope we build will ever see. Not because we're not advanced enough, not because our instruments are weak, but because the laws of physics themselves prevent their light from ever reaching us. Sean Carroll once said, "The universe is bigger than anything we can imagine, and it's getting bigger, faster." This is what he meant. The universe doesn't just expand, it expands faster the farther out you look. The result is a horizon beyond which the story of the universe is forever hidden from us. This isn't the kind of mystery that demands fear. It's the kind that invites acceptance. The kind that fits perfectly with that sleepy, late-night feeling of recognizing that you won't know everything and that you don't need to. Most people hear 93 billion light years as a fact, a number, a line in a documentary. But very few understand what it means. Most of that observable space is drifting away so quickly that future astronomers, tens of billions of years from now, will never see its light at all. Their night sky will be nearly empty. The cosmic web we see today, the filaments, the clusters, the continents of galaxies, will fade from view. And here's the part that lands deepest. No matter how advanced our telescopes become, parts of the universe are already gone from our story. Not destroyed, not vanished, just unreachable. The universe is not only vast, it is partial. We live inside a cosmic snow globe, able to see only the flakes close enough to glimmer. Everything beyond that remains forever out of reach. But instead of making the universe feel hopelessly large, this knowledge does something else. It gives you a kind of peaceful humility, a quiet understanding that there will always be things beyond knowing. And that's okay, because you, listening now, are one of the few people who understands not just the number, but the meaning behind it. You know what the cosmic horizon actually represents. You know why the observable universe is 93 billion light years wide. You know why vast regions of the cosmos will never reveal themselves. And you know that distance, true cosmic distance, doesn't just separate objects. It separates eras. It separates possibilities. It separates what can be known from what will forever remain silent. And that silence leads us straight to the next question, one that has troubled astronomers, physicists, philosophers, and dreamers for generations. If distance can hide entire galaxies from us, perhaps it can also explain why the universe seems so quiet. If the universe is full of stars and planets, where is everybody? That's the question Enrico Fermi asked one afternoon in 1950. And the silence that followed became one of the deepest problems in modern astronomy, the Fermi paradox. On paper, the universe should be buzzing with intelligent life. Hundreds of billions of stars, trillions of planets, a timeline billions of years long. The math practically begs for company. And yet the sky is quiet. But now, after everything you've learned tonight, the silence feels less mysterious and more inevitable. Because the answer that ties everything together is distance. Start with something surprisingly humble. Earth has only been sending out radio signals for about 100 years. A single century, just one human lifetime. Those first transmissions, weak, fuzzy, accidental, have been expanding outward as an ever-growing sphere with a radius of about 100 light years. And inside that entire bubble, the number of stars is tiny. Depending on the catalog, only about 400 to 500 stars lie within 100 light years of Earth, out of hundreds of billions in the Milky Way. That's not even 1% of the galaxy. It's not even a fraction of a fraction. It's a single droplet in an ocean. Humanity's entire radio footprint wouldn't even fill 1% of our own galaxy. Imagine standing in the middle of a national forest at night and whispering, not shouting, not calling out, whispering. Now imagine expecting someone, miles and miles away, to hear you clearly enough to respond. That's what our radio signals are like. Even worse, radio waves fade with distance, fast. The farther they travel, the weaker they become until they dissolve into background noise. For an alien civilization to detect us, they would need a radio telescope far more sensitive than anything we've built, pointed exactly in Earth's direction, tuned to the right frequency at the right moment, during the tiny slice of time humanity has been broadcasting. And that's assuming they even use radio at all. Now compare that to something you know well, 3i Atlas. The distance between Earth and Atlas is so small, astronomically speaking, that we can watch it change brightness by the hour. We can track its orbit with incredible precision. We can observe it in near real time. But stretch that out to interstellar scales, and everything changes. A near real-time update becomes a century-long delay. A shift we can detect in minutes becomes a signal too faint to rise above cosmic background noise. Even our fastest probes drift like dust in the void between stars. So the silence of the galaxy isn't a mystery. It's the natural consequence of light years. The distances between stars aren't just large. They're communication killers. They erase signals. They bury civilizations inside bubbles of detectability that last only as long as their technology survives. Two civilizations could live at the same moment, on opposite sides of the galaxy, and never know each other existed. Not because they're rare, or hiding, or extinct, but because the universe is simply too big for their messages to cross. Jill Tarter of SETI once said, "Absence of evidence is not evidence of absence." She meant that the universe might be full of life, but each civilization may see only a sliver of the sky, bright enough and close enough and recent enough for communication to be possible. And here's the part that brings everything home. Every civilization sees a different universe. Each one looks out into a bubble defined not by curiosity, but by the speed of light and the short lifetime of technology. Beyond that bubble, silence, not because nothing is there, but because nothing can reach. So the so-called Great Silence isn't eerie at all. It's geometry. It's physics. It's the quiet truth of light years themselves. And once you understand this, something shifts inside you. The silence stops feeling lonely. It starts feeling peaceful, natural, beautiful, even. Because instead of imagining an empty universe, you begin to imagine countless civilizations watching their own skies from their own tiny islands of observability. Each one listening, each one hoping, each one separated not by intention, but by the quiet tyranny of distance. We've been whispering for a century, in a galaxy the size of 100,000 light years. And that whisper may travel only a few hundred light years before fading forever. But that doesn't mean we're alone. It means we've only just begun to listen. Because distance doesn't only change what we can hear, it changes how we experience time itself. When you think about light years, one truth becomes unavoidable. The universe is simply too big for any ship, any signal, any traveler to cross in a single lifetime. Distances stretch across centuries, across millennia, across eras far longer than human memory. And yet, buried deep inside the structure of reality, there is one quiet exception. Not a shortcut, not a loophole, but a subtle trick built into the universe itself. It's the idea that time does not pass the same for everyone. Albert Einstein said it plainly. Time is relative. The faster you move, the slower time passes for you. This isn't poetry. It isn't science fiction. It's how the universe works. The faster you travel, the more time bends around you. Not in some magical sense, but in the precise, mathematical way space-time responds to motion. You can watch the effect in particles called muons, which constantly rain down from the upper atmosphere. At rest, they decay in millionths of a second, far too quickly to reach the ground. But because they move near the speed of light, their internal clocks slow down. They live long enough to reach Earth. Without time dilation, you would never detect them. You see the same effect in the technology you use every day. Your phone's GPS only works because the satellites above Earth adjust for both gravitational time dilation and motion-based time dilation. Without those corrections, your location would drift by miles in a matter of minutes. Even at those modest orbital speeds, time passes differently for them than it does for you. Now imagine pushing this effect much farther, far beyond aircraft, far beyond satellites, into the regime where starships would have to travel if humans ever attempted to cross interstellar space. At 90% of the speed of light, your perception of time begins to slow in a noticeable way. At 95%, the effect becomes dramatic. At 99%, a single year on your ship might equal 7 years passing on Earth. Push slightly higher, 99.9%, and the stretch becomes staggering. And this leads to the most startling consequence. If a spacecraft could maintain speeds close to light, a crew on board could reach a star 40 light years away and return after aging only a handful of years. While more than 40 years, an entire generation, pass on Earth. Imagine that. You leave home looking one age. You return to find the world older, your friends older, the news older, the culture changed. You've lived a few years. Earth has lived decades. This isn't fantasy. It's the natural consequence of moving through space-time at extraordinary speeds. As Brian Greene explains it, time is malleable. It warps, it stretches, it responds to motion. And that raises an incredible idea. We cannot break the speed of light, but we can change our experience of time. This is how physicists talk about cheating light years. Not by moving faster than light, that's impossible, but by letting time itself bend so the journey feels shorter for those aboard. Let's take a concrete example. A star sits 40 light years away, roughly in the realm of the nearer sun-like neighbors. At ordinary speeds, the trip is hopelessly long. But imagine a ship traveling at 99% of light speed. For the crew, the entire journey might take only a few years. The light outside rushes past. Time inside the ship slows. They are living in a different rhythm of the universe. Meanwhile, back on Earth, decades pass. Children grow up. Governments rise and fall. Technology leaps forward. People you once knew become older versions of themselves. When the crew returns, they step out into a future they didn't live through. Not because they jumped through wormholes or bent the laws of physics, but because they followed the rules exactly as the universe wrote them. This is where the connection to 3i Atlas becomes meaningful. For Atlas, time dilation is invisible. Its speed through the solar system is fast, but nowhere near the threshold where time distorts noticeably. But when you scale those speeds up toward the speed of light, which any interstellar traveler would need to do, the difference becomes enormous. Suddenly, a delay of minutes for Atlas becomes decades across interstellar space. Suddenly, communicating across light years becomes a conversation between generations. Suddenly, time itself becomes the limit, not distance. And this realization brings us to the emotional heart of the concept. Time is not universal. It stretches and compresses depending on how you move through space. You, sitting here tonight, live inside a steady, predictable flow of time. But the universe you live in does not guarantee that flow to everyone, or everywhere, or every traveler. Space bends it. Motion reshapes it. Gravity tweaks it. Time is flexible, fluid, responsive. And understanding that, genuinely grasping it, is a kind of superpower. It lets you see the cosmos the way physicists do, as a landscape where time and space are woven together, and movement through one reshapes your path through the other. If you flew fast enough, you could return home to a world decades older, while you've aged only years. That's not imagination. That's reality. A quiet, profound, staggering reality. And yet, for all its bending and stretching, time still returns us to one simple truth. We live small lives in a very large universe. Imagine yourself standing under a quiet night sky. No traffic, no screens, just the cool air, the faint hum of the world settling down, and a dome of stars stretching above you. In that moment, something happens almost automatically. The weight you've been carrying all day starts to feel lighter. Not gone, just smaller, easier to hold. That feeling isn't an accident. It's perspective. And after journeying through light years, galaxies, and the cosmic web, you're starting to understand why the universe has that effect. You live your life inside a narrow frame. Deadlines, responsibilities, expectations, financial worries, family concerns, the pressure to be everything to everyone. These things feel enormous at ground level. They fill your entire field of view. They crowd your thoughts. They keep you awake at night. But set them next to a universe tens of billions of light years across, and they begin to shrink. Not because they don't matter, they do, but because the scale around them changes. Perspective is peace. The universe doesn't take away responsibility. It doesn't erase the hard parts of being human, but it quiets the fear that everything depends on you. It reminds you that you are allowed to breathe inside your smallness. You are allowed to feel calm, knowing that your problems, like your life, occupy only a tiny corner of a galaxy that will keep spinning long after the moment has passed. And here's the deeper truth, the part most people never reach. Knowing what a light year really is changes more than your understanding of astronomy. It changes your understanding of yourself. Most people hear the term and think it just sounds cool. A word from sci-fi movies, a unit tied to far-off stars. They never think about the ladder of light seconds, light minutes, light hours you climbed earlier. They never imagine the timelines hidden in the night sky. They never feel the quiet realization that the universe is vast enough to hold their worries without letting those worries define them. But you do. You understand distance on its true scale. You see the night sky as a map, not a mystery. You belong to a very small group of people who feel light years instead of reciting them. And that sense of understanding has a softness to it, a calm, a gentle release. Even 3i Atlas, the object that's dominated so many headlines, so many conversations, so much anticipation, feels different through this lens. The excitement, the speculation, the tension, they all become easier to hold when you understand the distances involved. Atlas isn't racing toward us. It isn't a threat. It's a visitor moving through our cosmic backyard, still tiny compared to even the nearest star. Knowing that turns the noise around it into something steadier, something grounded, something you can follow without fear. Because light years don't just measure space, they measure perspective. They remind you that every joy you've felt, every grief you've carried, every milestone you've passed, every memory you hold dear, all of it fits into a moment so brief that the galaxy barely notices it. And somehow, that makes those moments more precious, not less. Carl Sagan once said, "For all our failings, for all our short-sightedness, kindness is what matters in the end." And physicist Alan Lightman wrote, "We are the temporary expression of an eternal mystery." That's what light years teach you. You are temporary, and that is beautiful. You are small, and that means your worries are small too. You are fleeting, and that's what makes the time you have meaningful. The universe is unimaginably large, but your life, your relationships, your choices, they shine brightly within the tiny space you occupy. They matter precisely because they are brief. And with that sense of peace, let's return gently to where we began. You've traveled a long road tonight, from yards and miles to kilometers, from light seconds to light minutes, all the way out to light years, the nearest stars, the wide disk of the Milky Way, the filaments of the cosmic web, the edge of the observable universe, and even the stretching of time itself. Your intuition, the one built for walking across a room, for driving across town, for remembering the length of a familiar highway, has been gently reset. Tonight, you rebuilt it on the scale of light. And now, as everything slows down again, the universe around you feels softer, quieter, easier to hold. Somewhere out there, 3i Atlas is still drifting through the solar system, a cold speck slipping through starlight, following a path older than anything on Earth. It isn't rushing. It isn't changing the night. It's simply moving through its brief moment in our sky, the same way every visitor does. Everything is calm. Everything is steady. There is nothing you need to do. Because tonight, understanding took the place of worry. Light years, these enormous, humbling units, didn't make the universe frightening. They made it peaceful. They gave you perspective. They helped you see how distance and time weave together into something vast but gentle. And that's the quiet gift of learning scale. When the universe gets bigger, your fears get smaller. Understanding light years doesn't just help you read a scientific headline, it helps you read your own life. Deadlines, expectations, the pressure to carry too much, all of it becomes lighter when placed next to billions of years of starlight. Not because those things don't matter, but because they no longer fill the entire sky. Tonight, the universe invites you to rest in what you don't know. Not everything needs an answer right now. Some questions can be left for the cosmos to hold. Some mysteries can wait until morning. Some stories, like Atlas, can unfold at their own quiet pace. Let the night take the weight from your shoulders. Let your breath slow. Let your thoughts drift to the edges of everything we explored. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." And Brian Cox added, "We explore the universe, not because we need to, but because we long to." That longing brought you here tonight, not to solve the universe, but to sit with it, to feel its size, to learn its rhythm, to let its scale make your own life feel gentler. And in that gentleness, something beautiful appears. Fear becomes respect. Respect becomes understanding. Understanding becomes calm. Fear is just respect for the unknown, softened by understanding. So let the questions fade for now. Let the stars hold them. Let the darkness become a blanket instead of a boundary. You don't have to understand everything tonight. The universe isn't in a hurry, and neither are you. Sleepy Universe will be here when Atlas speaks again. When the next update arrives. When the next discovery ripples across the sky. But for now, light years have done their work. They've lifted the weight from your chest. They've placed you softly back into your small, beautiful corner of the cosmos. Close your eyes. Let the night be simple. Let the universe be quiet. Good night. And until the next chapter of Atlas, let the stars keep watch for you.